Hello, and let's take a look at this question. If the sum of squares of two numbers is 97, then which one of the following cannot be their product? Okay, so sum of squares of two numbers, let's say these two numbers are a and b, and the sum of squares is a square plus b square. Whenever someone says a square plus b square, we inherently identify some terms along with it, which is 2ab. Now, let's say I want to get a plus b whole square is equals to 2ab, and a minus b whole square is a square plus b square plus minus 2ab, right? These are the two major identities that are associated with a square and b square. Fair enough. So we have this value a square and b square, right? And we have to figure out what cannot be the value of ab. Fair enough. Now the one way to do this is figure out what values this function can take so that we can identify the range for the RHS, right? Because they are in equality, the range on LHS will be applicable to range on RHS, right? So any value when squared has to be greater than or equal to 0, right? So a square plus b square plus 2ab has to be greater than or equal to 0, which means a square plus b square has to be greater than or equal to negative of 2ab. Similar thing if we do for a minus b whole square, great, this also has to be greater than 0 because it's a square of a value. The least it can be is 0 and the maximum it can be is infinity, but it cannot be negative. So if we do the same thing for a square, a minus b whole square, a square plus b square minus 2ab is greater than equal to 0 and a square plus b square is greater than 2ab. Okay, now when we look at this, we can identify one thing. If I say modulus of 2ab, then this will be opened up into plus 2ab and minus 2ab, right? So if I have this, then can I not say that a square plus b square has to be greater than or equal to mod of 2ab, right? I can say that. So in that sense, if I say a square plus b square has to be greater than 2ab, if 2 is positive, I can take it outside of the modulus. So a square plus b square divided by 2, it has to be greater than mod of 2ab. Now I have something which can tell me the maximum value of ab, mod of ab, right? If we come back to the question, we have a square plus b square is equals to 97, right? If we put this value in equation number 1, then 97 by 2 is approximately 48.5. Not approximately, exactly, it's 48.5, which has to be the maximum value a and b can take, mod of a and b can take. Now here in the example, in the options given, 48 mod is less than 48.5, 16 mod is less than 48.5, minus 32 mod is 32, which is also less than 48.5, but 64 is not less than 48.5, hence option A is my answer. Now once this method has sunk in, let's look at another method to solve the same question. Okay, another method to solve the same question will be, let me just rub this off. Okay, we have a square plus b square. Now two cases we can make, 2ab and minus 2ab, right? That's all we can do. Now we know if I say that my ab value, let me just make this table once more. If I say my ab value is 64 minus 32, 16 and 48, my 2ab should be double of this, so 128 minus 64, 32 and 96. Fair enough, right? A square plus b square plus 2ab has to be greater than equal to 0. We just saw this before. Also, a square plus b square minus 2ab also has to be greater than 0 or equal to 0, right? These two conditions have to be satisfied, because square function will never give us a negative value. Fair enough. We already know a square plus b square is 97. So 97 plus 128 is obviously greater than or equal to 0. It's greater than 0, strict in sense. Fair enough. So this is okay. If I say 97 minus 64, still it's okay, it's greater than 0. 97 plus 32, greater than 0, works. And 97 plus 96 still is greater than equal to 0. So here I did not find any contradiction, so it's okay. Okay, this is fine. But in this, 97 minus 128 is not greater than or equal to 0. Here we found our answer, which is 64 directly. I don't need to check all of them, because 97 plus 64 is anyways greater than or equal to 0. 97 minus 32 is greater than 0, and 97 minus 96 is obviously greater than 0. So I don't need to check all the other options. I immediately know by this that my answer is 64. I hope you like this, and I'll see you in the next one.